Lesson is on linear transformations, shifts, and reflections. So shifts is like a translation up or down or left or right, depending on if you're horizontal or vertical. So the first type is going to be a vertical shift, so a vertical translation up or down. So think about when we did vertical stretching and compressing. The function rule was a times f of x, and we knew it was vertical because the a was outside of the f of x. It was being multiplied by f of x rather than being multiplied inside the parentheses with x. So we knew that that was vertical because it was on the outside. Same thing is going to be here. We know that this is going to be a vertical translation if the number that we're adding or subtracting is on the outside. You'll see with the horizontal shifts that it's the plus or minus a is going to be on the inside of the parentheses. All right, so a is outside of the parentheses. It's a vertical shift. It's going to shift it up or down. So if a is greater than 0, so basically if a is positive, then the graph of g of x is a vertical. I'm going to type because it's a little bit easier. So it's a vertical shift. You could also say translation, that's fine. Up a units. So if it's f of x plus 2, it's a shift up 2 units. Every point shifts up 2 units. And then if a is less than 0, so if it's negative, then the graph of g of x is a vertical shift and then down a units. That's because if you're subtracting from all of the y values, it's going to make it go down. So here we're either adding a number to the y values or subtracting a number from the y values. So we are going to use, and the graphing for this page will be optional because I'm just going to show it to you in Desmos. But the first example is going to be f of x equals x plus 3. And then your function rule will be g of x equals f of x plus 4. This is going to be causing a vertical shift up 4 units. So first of all, let's write the new function g of x. G of x, if we write it in terms of f of x, will be f of x plus 4 or x plus 3 plus 4. And then we would reduce. So g of x will be x plus 7. Now I'm going to take f of x and my new g of x, and I'm going to plug them into Desmos and get a visual look at the graphs. So instead of f of x, you'll type y equals x plus 3, and then y equals x plus 7. So if I look, you can like hover over any point. This point is at 0, 3. This point is at 0, 7. It translated it up or shifted it up 4 units. If I look at this point, maybe this doesn't do a great job of showing me the points, shows me the intercepts. This is at 0, this point is at 4. This point's at 2, this point's at 6. Even if I go all the way up here, this point's at 10, this point is at 14, y equals 14. So every point is being shifted up 4 units. All right. And if you accidentally like zoom out, because some of you guys like to scroll out and see what the graph looks like from afar, just press the home button to get back to the 10 by 10 window. Now let's see what happens if we have a different rule. So you still the same f of x, but now h of x is going to be f of x minus 4. So this will look like x plus 3 and then minus 4. And then I would simplify that as x minus 1 because 3 minus 4 is 1. So now I'm going to type that into the second line, or the third line rather. Y equals x minus 1. So now I see that the red line is now shifted down 4 units every coordinate. So it's not stretching or compressing anymore like the previous lesson. It is now just being shifted down 4 units. So whenever the number is outside of the parentheses for your function rule, you consider a vertical shift either up or down. Now the next type is horizontal shift. Just like with horizontal stretching and compressing, the number inside the parentheses is always going to work opposite of what it would look like outside of the parentheses. So the rule here is g of x equals f of x minus a. So if a is greater than 0, then the graph of g of x is a horizontal shift up a units. So if a is positive, it'll be shifted up 2 units. The only thing is, what that's going to look like is f of x minus 2. So for example, if a is 2, it'll be f of x minus 2. It looks like it's negative though, because in the formula, it's x minus a. But actually, you can consider that the negative sign is part of the formula, so a would actually be positive 2. So here, a equals 2. If a is, and bear with me, this part is a little bit confusing, but it'll make sense in a minute. So if a is negative, then the graph is a horizontal shift. Oh, I'm sorry. Instead of up, you should be saying, not up, right, a units. So this is a horizontal shift left a units if it's negative. But in the form, what that will look like if we consider 2, it'll look like f of x plus 2. Because actually, if the formula is negative, it would be f of x minus negative 2, because 2 negatives make a positive. So here, a equals negative 2. So basically, whatever you see inside of the parentheses, it's the opposite. So if you see x plus 2, that means it's negative 2. If you see x minus 2, that means it's positive 2, and it's moving it to the right. So x minus a number is moving it to the right, x plus a number is moving it to the left. And just like with horizontal stretching and compressing, we're going to look at how it moves horizontally. So let's take our same equation, f of x equals x plus 1. And then for g of x, let's look at f of x. Let's do the 4 example again. So let's go minus 4. So for the equation, we're going to replace x minus 4 with x in this equation. So actually, you know what? I'm going to change this a little bit just so it's a little more complicated. Let's, instead of x, let's do 2x. So when I plug this in, it's going to be 2 times x minus 4 and then plus 1. Instead of x, we have x minus 4. And then I simplify. So that would be 2x minus 8 plus 1, which makes minus 7. And let's graph both 2x plus 1 and 2x minus 7. Okay. So if I look vertically, it looks like it's being shifted. This is 5, this is negative 3. It looks like it's being shifted 8 units down. And then this is 3, that's 5, 8 units down. But actually, if I look horizontally, it's being shifted from the red line to the blue line. It's being shifted 4 units to the right. Here to here, 4 units. 2 to 6, 4 units. -2 to +2, 4 units. So x minus 4 caused a horizontal shift 4 units to the right. And then let's see what happens if we have h of x equals f of x plus 4. So if I plug that in, it would be 2 times x plus 4 plus the 1. And I realized I accidentally picked 1 where up above it was 3. That's okay. So this would be 2x plus 8, and then plus 1, which would be 9. So let's check what that looks like. Let's change this to plus 9. Here it's looking like it's moving from 0 to -4, so 4 units to the left, like we would expect. So x plus 4 causes a horizontal shift 4 units to the left. So once again, when I see x plus 4, it's moving it to the left in the parentheses. So it's the opposite of in the parentheses. All right, reflections. So what happens when I reflect my graph? So let's use the example that we did in the last one, f of x equals 2x plus 1. And let's use the first bullet point there. So g of x equals negative f of x. So this means we are going to be doing a negative parentheses and then basically multiplying the entire f of x by a negative. So 2x plus 1. That's going to change out all the signs. So g of x will be negative 2x minus 1. And let's see what that looks like and what happened if it reflected across the x or the y-axis. So 2x plus 1, negative 2x minus 1. So if I take this line and I make it go across this line, it reflects in the x-axis. So what I'm doing here is if I have the negative sign in front of the y values, I'm making all of the y values negative. So it creates a line that goes like this, and it flips the sign of all the y values. So now it's going to go down. So reflection across the x-axis. And then if I have h of x equals f of negative x, and I'm only making the x negative. So now instead of 2x plus 1, it'll be negative 2x plus 1. So let's see what that looks like. I'm going to change this to plus. So I took my red line and then to my blue line, and it's reflecting it this way because the y-coordinate stays the same. So it's no longer a reflection about the x-axis, it's the y-axis now, because I'm taking all of my values and I'm swapping the x values. I'm making them the opposite sign. So now this point is going to be over here, this point is going to be over here, this point is going to be here. So see how 2, 5 is now negative 2, 5. And let's see, 1, negative 1 is now negative 1, negative 1. So this would be the y-axis. Okay, let's do some examples. It says, write the new function given both functions and describe the transformation. So f of x equals 2x minus 1, g of x equals f of x plus 3. So that means we do g of x equals 2x minus 1 and then add 3 at the end. So it would be 2x plus 2 because negative 1 plus 3 is 2. So what this would do, it would cause a vertical, because the 3 is on the outside of the parentheses, vertical translation up 3 units. And we can graph it. So this is 2x minus 1. So that's down here, and it goes up 2 over 1, up 2 over 1. This goes down 2, left 1, down 2, left 1, down 2, left 1. And then the other one is 2x plus 2. So starts at 2, goes up 2 over 1. So notice the slope for these is staying the same. So this is G, this is F. All right, and then for part B, 3x plus 1, f of x minus 2. So g of x will be 3x plus 1 minus 2. So this would be 3x. 1 minus 2 is negative 1. So 3x minus 1. I will let you graph both of these, and then for the description, write that this is a vertical translation or shift down because it's minus 2 units. For part C and D, these questions are horizontal shifts because the number is in parentheses, and remember it would be the opposite. So let's write down the new equation. So 2, and then instead of x, I plugged in x plus 3 minus 1, which would be 2x plus 6 minus 1, which is plus 5. And this would cause a horizontal shift, and then it's the opposite. So if it's plus 3, that means it's negative, which means it goes to the left 3 units. And with this one, the equation would be 3 parentheses x minus 2 plus 1. So 3x minus 6 plus 1 would be minus 5. So 3x minus 5. And then the description, you would write horizontal shift 2 units. And then since it's x minus 2, it's the opposite, so it goes to the right. So 2 units right. And I will let you do the graphing on your own. E and F. E is 1/2 x plus 1, and then you're doing negative f of x. So I take negative, oops, I don't know why I keep typing 9, negative parentheses 1/2 x plus 1. So I'm multiplying the negative sign by the entire thing. Remember, it's like negative 1. So I do negative 1 times 1/2, which is negative 1/2 x, and then minus 1. For the description, you would write that it's a reflection in the x-axis because all the y values are being negative or being opposite sign. And then for this one, the negative sign is inside of the parentheses, so only the x gets the negative, not both numbers in the equation. So t of x will be negative 1/2 x plus 1. And this would cause a reflection in the y-axis. right? And then the last page in your notes, we are going to save for Friday's lesson for periods 2 and 3. You will need to watch the video of the mixed review. So don't forget to do that. Okay, you will have a quiz on Monday, and I will have the quiz review in Edulastic for you, either Edulastic or paper for you on Friday in class. Okay,